Well, hello everyone. Welcome. We're delighted to having you here today to this webinar session, Understanding the Engine Diagnostics Communication Architecture for a Correct Omics Maintenance. Thank you, Patty, Laura, and the IBEX organization for having us here. For the audience, we're going to be at the next IBEX show. So if you want to meet us in person, just come by and we're going to say hi. We can discuss about all of this. So all the lines are in muted today, but we want you to participate, and you have a Q&A box that you can find it in the Zoom app. Just type anything, click send, and at the end of the presentation, we're gonna have a Q&A session. And if some of the questions are not answered, we're gonna send emails to everyone. This will be recorded, and you're gonna receive a thank you email and also the on-demand link of the webinar session. Okay. So yeah, let's get started. So first of all, we're three of us today. Jose Perez, he is our technical assistance manager. He is an actual certified technician. We hired him from official dealers, so he's just like you guys. He knows your struggles, deadlines, anything you have to do every day in a shop, and now he takes care of the customers. So it's going to be fantastic to have him here today. Thank you, Jose. Then we have Jesus. He's our marine engineering manager. He's in our headquarters in Spain. So he's in the afternoon right now. He has been in the project for almost 10 years. And if he's not the engineer worldwide with more knowledge in omics diagnostics, there's not going to be too many like him. So it's going to be a good thing to have him here today. My name is Ignacio. I'm the marine director. So we're be covering different type of areas of the company, business, technical assistance, and the engineering side. So it's going to be very good for you guys, for the audience. Okay, so introduction, systems, electronic control models, communication. This is the index, diagnostics, functionalities, extra features, technical assistance, and Q&A. This is going to be the index for today's session. And first of all, it's just going to be this slide, who we are. We're a company, Kajali. We are specialized in different type of business lines. Everything is focused for the technicians, for the workshop, for maintenance. We have different divisions like diagnostics. Obviously, Jaltis Marine, it's inside this business line. Telematics and remote diagnostics. We have a specific software and technology for the agricultural sector, replacement parts, and we can also do all kinds of things for OEMs and big companies, because they rely on us because we're very good in what we do. Just this is going to be an industry-oriented seminar, and let's get started. So we have first a fantastic quote from Bill Gates. Okay, so it's we don't realize how technology is changing constantly without even noticing it. We believe it's normal because it's part of our everyday life, but not so long ago, we can go 500 years ago, it was pretty much the same than 1,000, 2,000, 3,000, 5,000 years ago. So we want to see, what happened. Okay, so we had a great evolutions like 200 years ago. Everything got crazy with the steam machines, the internal combustion engines, and everything changed. Um, our works, our transportations, our the way of we have our relationship between human beings, environment. Okay, so right now everything is changed. A lot of technology. We are more connected, and we want to know what happened. Okay, because right now it seems like everything is possible. So first of all, what would have happened if we didn't have all this kind of evolution? Okay, so of course we don't have any kind of big cities, any huge population right now. I don't know if we have 7 or 8 billion right now. That means friends, customers, family, colleagues, no cars, no phones, no internet, no planes, and obviously no boats. Okay. But what kind of boat? No, well, obviously these modern boats that we currently know at the moment. So we would still be like this, with some wooden boats, and actually even a tree. Jesus was telling me that the first way of transportation, it was a tree, just a tree to cross a river or a lake, and even way before the wheel was first created. So in your case, all the technicians, what would be your situation if we didn't have all that technology? Well, you will be fixing donkeys, or you will be fixing like wooden vessels. And in our case, the manufacturers, we would be producing veterinary supplies or handcrafting tools. Okay, so thanks to all those geniuses and people that they were able to create all this kind of technology, and especially in the last previous years with the internet and electronics industry. We can go back to the present with the boats that we have, so we can analyze, the industry, because something new is happening. Okay, so what is diagnostics? So diagnostics is, the definition is to collect and analyze data to evaluate different types of problems. Okay, and then all are based on symptoms, and then we need functionalities in order to repair them. This is a typical structure of diagnostics. Okay, this is going to be, for example, on the vessel. This number one is the electronic control unit or electronic control module, is exactly the same. These are the brains. This is controlling everything. It's receiving information from the sensors, and then it's sending all the actions to the actuators. Okay, so number one, we have the ECM. Number two, we have the sensors. Number three, we have all these actuators. Okay, then we have two other elements. We have this is going to be the diagnostics line. So this is the communication line between the ECM, okay, and all the sensors and everything with the diagnostics platform. And then we have B, okay, these are the CAN lines. So this is the communication line between the different ECMs that we have in a single vessel, okay, because we can have different engines, we can have all the type of systems, central computer, digital levers, okay. Then what do we have on the diagnostics tool side? This is wire connected to the link interface, and then this is connected to the software, to the device where we have all this on the platform. Okay, it can be an OEM or all makes. It's going to be working exactly the same. Okay, so what is the origins of diagnostics? We can say that we have first step one and step two, but the origin is there was a need of being more efficient, to have a better performance, uh, less fuel consumption, less pollutant. Also, in a safety side, being able to monitor all the sensors, pressure, temperature, etc. Being able to have a higher control of injection dosage, etc. Okay, so this is the start of diagnostics. It started like with electromechanic engines. Only the pump was electronically controlled, and then we had electronics on the rest of the engines. Okay, then we have inside the step one. Okay, so we have the engine or multiple engines. We have other ECMs. No, I was saying before, like central computer. These are levers. We need to do a pairing to know how many engines we have, where they're located, etc. Okay. Also for the after treatment systems, at some point we need an additional system so we can control all that. Okay, so that's important. So that was step one. Then step two, we have all the repair functionalities, because this at some point we're gonna get focus, we're getting situation is electronics, and we need repair functionalities in order to repair those systems so they're working again. And this is gonna be like a constant situation until the vessel is going to be scrapped or the engine and we cannot use it anymore. Okay, so this is important to know that we have all this origin of electronic systems, and then step two, all the repair functionalities in order to repair it. Okay, this is very visual. We have a mega yacht here with multiple systems. Okay, so I think we have 8 or 9 electronic system with 8 or 9 electronic control modules. Okay, so we need to connect to each of them. We have, for example, this is an example with two Cummins engines. Okay, we have port and starboard, and then we have all those peripheral Mercury Smartcraft systems to control the vessel. Okay, so as we can see, we have all systems, okay, because it's not only the engine, and we have all makes. Okay, we have different manufacturers. So right now it's why all makes diagnostics. Well, we have all kinds of engines. We can say that we have 4 types: inboards, outboards, jet skis, and stationary engines. Okay, and we also have all type of fuels. In this case, going to be gasoline and diesel. Okay, so this was the start of all makes. We need to do things easier, and this is like the reality. You can just, instead of having multiple OEM tools, you can just go with one customer support, one license, everything. And it's important to know that in the marine industry, if you're not a dealer, you don't have access to most of the tools. So it's not possible to be in a dealer of everything. And so we can go with an all makes platform, which I want to highlight in a couple of slides, or maybe more, that we're not enemies. We're both part of the industry. All makes exist because we have OE softwares, and it's just like an add-on, and it's just something to provide solutions for the customer. Okay, so I want to do like a pros and cons slide for the OE channel and then the OMX channel. Of course, we have pros. For example, deepest level of diagnostics coverage for a specific OE. That's totally true. And then we have a lot of cons. No, it's going to be more expensive. We need more training sessions. So we have different platform, steep learning curve. You know, you have to go with all kinds of different customer support teams. No, if you are not a dealer, you don't have access to the technical information. So obviously there's many cons. On the OMEG side, cons, obviously, lack of some advanced functionalities like ECU reflashing, but then pros, so I don't repeat things that I was saying before, dealer level diagnostics coverage, regardless of the make or system, faster return on investment, you know, one training session, one customer support, one everything. So obviously there's many pros by using an OMX platform. This graphic, I really like it a lot because we can see the learning curve. Now, if we are using different OEM platforms, you have to learn one and you have to start all over again. With an OMX platform, you can just learn one platform and grow that snowball of knowledge because it's the same platform, same way of using it, okay? As I was saying before, we're not enemies. You can use this Nullmax platform as your first tool, or it can be like a second tool. You can be a dealer, or you can have another Nullmax platform, but then maybe you need extra coverage, and then you decide to have another tool. Okay, so it's everything is to provide solutions to the customers, and we have a lot of arguments like surveying. A lot of surveyors they use Nullmax platform is much easier to just go with one mobile repair, no, OEM restrictions. I was saying before, no, expand the coverage. Also meet all your customer needs. No, you can have a customer with different type of makes and models. If you're not able to provide maintenance to all the makes and models, they're just gonna go with multiple technicians or just find the one that's able to do that. Okay, and obviously it's an investment to generate more income or save it if it's your own fleet of vessel, or if you're a chief engineer of a mega yacht. Okay, potential users, everyone involved on the maintenance side, obviously independent technicians, obviously end users. I was saying the example of chief engineers with the mega yachts, institutional, I will say all what is the military, US Coast Guard, etc. Dealers, okay, a lot of dealers they use Omex tools to have that extra coverage, shipyard, etc. But again, anyone involved on the maintenance side. Okay, these are the main tools. Okay, we have the two main ones on the gasoline coverage side is Rena Diacom, and we have all the CDI meds. And on the gas and diesel side is going to be Texas and Jaltis. Okay, so you can see what are the main tools on the Omex industry. Okay, what is the coverage? Two slides. Okay, it's going to be recreational and industrial. Okay, so in recreational, jet skis, jet boats, outboards, inboards that are stern drive, racings, inboards and outboards. Okay, but again, I think something that on the industry was lacking, especially on the diesel side, anything. Mega yacht is recreational, but I think it's big enough to be included in the industrial side. Tugboats, fishing boats, anything. Okay, so it's important to know that with one tool you can have a coverage for different type of vessels, different type of engines, different type of fuels. Okay, so now let's see the insights. Well, I'm going to start with the outside. Okay, how does it works? What is the technology? All the elements. Okay, and then Jesus, he's going to be talking about the insights. The beauties in the inside, and he's going to explain all the beauty about all this technology. So let's start first with the hardware side. It is a common structure. We have the engine. The engine has an electronic control unit. The electronic control unit has a diagnostics port. You connect the cable, the proprietary cable from the make and model where you are. Then this is connected to the link interface, and then this is connected to the device where we have the software installed. Okay, so here we can see like a bigger image, like a real image. It's the computer. It is wireless, connected to the link interface. We have the cable. It's connected to the ECM. We don't see it here. It's in the inside, and then is the engine. So this is a typical structure. Okay. So now Jesus, who is our marine engineering manager, he's going to explain all the insights, all the communication protocols, and we're going to be covering pretty much 99% of all the communication protocols.
Yes, thank you, Ignacio. Hello everyone. It's Jesus Garcia Cano, Marine Diagnostic Team Manager. Today we talk about most marine communication protocols. Well, it is possible to divide on the following list: the CAN line, J1708, K line, and others. RS232, GMUR, CDL. Okay, well. One important thing today we talk about the physical communication layer, okay? Because in communication protocol exist different layers, okay? Link, application, and transport layer, but we put the focus on on physical layer. Sorry. Okay, well, we will start with the most common communication line is CAN line. This CAN line was developed by Robert Bosch company in the 80s of the past century, and in the 90s of the past century was released by Mercedes-Benz. Okay, and they released this technology. Okay, it's a bus topology. That means all the information from the control unit are through this backbone. Okay, and share all the information at the same time in this backbone. Okay, the lines is symmetric quadratic redundant signal. Okay, we have two different lines. Okay, CAN high, CAN low. It's quadratic because the form of the signal is quadratic. The high side is 1 and the low side are 0 in binary. Okay, and it's redundant because we have the same information in both lines. If we could, for example, the CAN low, we maintain the information in the CAN high side. Okay, obviously generate diagnostic error, but the information is in the line. So it's a very sure, very stable communication. The control unit use a source address. Every control unit have a direction, okay, a address. And for example, in J1939, the engine is source address 0, the engine 1. The engine 2 is source address number 1. Okay. Another important thing, and through this backbone, the information is information from the control unit and diagnostics functionalities. Okay, so are together in the same messages. Another important thing is this kind of lines have two terminal resistor, one here and one here. And this terminal resistor is 120 ohms each one. And the best way to check if these resistors are okay is to put here in the diagnostic socket, put the polymeter and to measurements the ohms. Okay, if the measurements is 60 ohms, the resistance is okay. What happened? 60 ohms because in parallel circuit, the summatory of the resistance is the inverse of the summatory of the inverse resistance. Okay, let's go. One of the most important protocol application is J1939. It's probably in automotive environment is the most important communication. In marine also, all of these brands who use J1939. Okay, Ilmor, Inmar, PCN, Crusader, Cummins. Okay, and this protocol is a standard, is a norm, and all manufacturers follow this norm. Look at this. This picture is a OBDM connector. Is really important and interesting for marine sector because it's a standardized socket. This standard socket is used by American manufacturer of gasoline engines. It's really nice because with just one connector, we can connect to a lot of brands like Ilmor, Inmar, PCN, Crusader, even Mercury for the inboard engine, newer, Volvo Penta gasoline, Mefi 6, 5, 6, and 7. So it's really nice for us and for the final user because with just one cable can connect to every brand. The pinout will be positive, ground, can high, and can low. Okay, for that order. Okay, ENMIA 2000 probably is the most famous communication in marine sector because it's the marine standard. It's not really important for the diagnosis because the manufacturer of engines or this kind of system don't use this communication. But for example, GPS, radio, sonar, radar, yeah, they use the ENMIA 2000. For example, Evinrude G2 used the structure of EMEA 2000, but the language is not in EMEA 2000, but they use the cables. Here we can see very well the structure. Here we have 4 T connector with four different nodes, okay? For example, the first node will be the engine, GPS, radio, sonar, and here we can see very well two terminal resistor. Okay, and for the last in that picture, we can see the EMEA 2000 connector, and this is the standard pinout. Okay, probably the people knows very well about this pinout. Okay, proprietary CAN protocol in marine sector. I think the most important is Mercury G3 or SmartCraft. Here we have an example of a structure for every Mercury with this technology. Here we can see 3 different CAN bases. CAN H, don't confuse because it's not cat high, it's CAN helm, okay? CAN P is CAN propulsion. CAN X is internal DTS communication. DTS is the digital through the land shift, the levers. Okay, so in one connector we can find 3 different CAN bases. Okay, this is the junction box where share all these buses, and the rest of the modules we can see the CCM is command control module for the control levers. And in this case, the one key is for diesel engines. Mercury, the diesel engine is not manufactured by Mercury, is manufactured by a third-party company, for example, Volkswagen or VM Motori. And these modules talk in different language, in different protocol of SmartCraft, and they use the system integration module, this module, to convert this information to SmartCraft protocol. Okay, in the case of the gasoline engines, it's not necessary. This is the key too. It's not necessary because the manufacturer, this control unit is Mercury. So, okay, and the last of the module is TVM, is trash vector module to control the direction of the boat. Okay, with joystick or something like that. Okay. Now finish with the main CAN lines protocols. Now I'm going to start with J1708. It's a very common protocol in marine because Volvo Pinta use it for the technology A, B, C, D, and E. Okay, the newer one, the EVC2, use a CAN line protocol. So as you can see, the most common always is CAN lines. Okay, the J1708 but it's a vast topology, also like CAN lines, And the maximum system in the same bus is 20 system. In nautical sector, it's not common to have more than 8 system, but this protocol is prepared to maximum 20. Okay, the signal is different. It's not quadratic. It's like this, like the picture, and it's balanced. Okay, it's not symmetric. This protocol don't use source address. They use the identifier, message identifier. For example, the message identifier of engine is 128, and the lines for diagnosis is the lines is only for diagnostic, not for share information. Is the main difference with compare with the CAN lines. Okay, brands that use this kind of protocols is Volvo Penta, D3 Diesel, MTU 60 series. Okay, here we can see a example of Volvo Penta architecture. Here we can see 2 engines and 2 different buses. Okay, one in port side and the other one in the starboard side. Okay, if normally in Volvo Penta the diagnostic socket is in the engine block, and we can connect to the all modules connected in the port side. For example, if I connect here in the port side, I connect to the engine, obviously, the powertrain control unit of the port side, the health control unit number 1, the health control unit number 2, in the number 2, helm 2, and health control unit in the helm 3. Okay, so remember the structure is different two kind of buses. Okay, we change now. We finish with the buses, and now start to talk with request and repose communication, not bus. Okay, the K line is a single wire, and the lines are only for diagnostics, no share information between control units. Here in the example, we can see a MAN typical structure. Okay, MAN engine. Here we have 2 different control units, the electronic engine control module, and SFFR is like a body computer. Okay, with just one line, we can make diagnosis in one of these control units. And the communication to share information between control units is by CAN, but this CAN is not for diagnosis. To make diagnosis in this kind of control units is necessary by K line. Okay, brands that use this kind of technology is normally the Japanese, like Yamaha, Suzuki, Honda, Kawasaki, Tohatsu. Selva is Italian, but they use the Yamaha technology, FPD Iveco, MAN. Okay, others important is the RS232. In this case, we have 3 lines. It's also like a K line, repose and answer. Okay, but not with one line. With 3 lines. Okay, RX, TX, and ground. Okay, another name for this communication system is serial port, COM port, and this line is only for diagnosis and reflection, the control units. It's an early communication method. It's very common, obviously, in computing. Probably people remember the old printer that use this kind of communication. Okay, here in the example, we can see a structure. TX is transmission, RX is reception. Okay, so the control unit transmit the message, and the diagnostic tool, transmit the message, and the control unit receive the message. And the answer is the control unit transmit, and the diag tool receive. So like that, we close the communication, and it's necessary a common ground. Okay, brands that use this kind of communication is Evinrude, Futuram, and Evinrude eTech. Okay, another brands like Weber and MTU MDEC modules also use this kind of communication. Okay, and others proprietary communication is not the standard, and for example, is GMUR. one line. It's like K line, but inside the communication is totally different. It's used only by General Motor Group. Okay, General Motor create this protocol, not the standard. The system that use this protocol, MIFI 1, 2, MIFI 3, 4. Remember, the newer one, MIFI 5, 6, and 7 use J1939. Okay, and the last one, for me, another important protocol is CDL, similar to J1908. It's used only for Caterpillar. CDL means Caterpillar Data Link. It's only for diagnostic, not for shared communication. Okay, I finished my part. I hope you understand and you learn with my topics. Thank you for your time.
Hi, I think you're seeing my screen right now. Again, yeah. So so right now we go to the diagnostics functionalities. We're explaining before. You have like that origin of diagnostic. We have a step one, all the systems, all the electronics, the communication protocols. But then that step two thing, we need diagnostics functionalities so we can repair everything. Okay, so this is important. So right now let's start with the diagnostics functionalities. This is like an index thing. We have three types of diagnostics functionalities. We have reading functions, we have bidirectional functions, and we have advanced functionalities, which are some kind of bidirectional functions, but is the advanced ones where we can write on the ECM. Okay, so we have, it's not just reading focus, we have all kind of information. All this is the necessary features for any technician. Okay, so first of all, reading functions, we have what we call guided diagnostics. Okay, it's not only providing dealer level proprietary fault codes, but then the technicians, they also need extra information, especially when they're using an Olmecs platform. Right now we're in a Yamaha outboard. If the platform has technical information, it was like a hyperlink, you can check what is the component related to the fault code, what is location, operational values, wiring diagrams, and also that's all part of that information that technician need in order to repair all the problems. Okay, then we have operation data. This is also a repair function. It depends on the manufacturer what you can see or not. This is also an example with another Yamaha outboard. You can have, for example, the hours of use with the different RPM ranges. This is also interesting and useful for surveyors when you're doing brokerage. And then the second option is the abuse data. So we can not only connect and see fault codes, operation data, operation hours, but also the abuse, no? And then when you're buying or not or things, you can evaluate all these situations. System data is like the ID of the engine, whatever has been registered by the manufacturer. This example is with an heavy road outboard, so you can see the engine type, serial number, etc., etc. Okay, this is also reading functionality. Then we have the measurements, live measurements, super important to monitor our sensors. Depending on the Olmecs tool that we're using or the OEM platform, we're going to see it in one way or the other. We can have like a live dynamic displays, graphics, gauges, etc. Okay, and something that's crucial on the marine side is doing sea trials, no? Because, for example, obviously you can find other OEM or Olmecs platforms in other type of industries, but what you find is just one engine. But with marine, you normally find multiple engines, and at some point you can even have like, I don't know, if you want, you can just start to put a lot of outboards on your vessel. So you need to know what is the performance of each engine, because you need like a similar performance. So with a data recorder, you can record everything you're doing. You can select some kind of measurements, and then you can go back to your shop and you can just click play and know exactly what happened. And also if you have like intermittent focus, you don't know when they're happening, you can just record everything, go back, you can add your notes. So this is especially useful for marine technicians. Okay, now we're going to go with the bidirectional actions. Jose is going to explain all this 4 different slides.
Alrighty, thank you guys. So Starting off with cylinder cutouts, that's a very common bidirectional function used in the industry. One of the most used functions, I think, and it's useful because say you have an engine misfire and you're not quite sure which is the cylinder with the engine misfire or the one that's not functioning properly. Well, using this bidirectional function, you can cut out each cylinder individually. As you can see here, this one would be representing cylinder 4 cutout. And then you can monitor how that cylinder shutdown affects the engine speed, how it affects the operation of the engine compared to the other cylinders. That way you can identify where the issue is, which cylinder you have the problem with. And going on to actuating components. Actuating components is very useful because, for example, with this test, actuate the injector. Say this is different than a cylinder cutout in the way that with this test you would have to have the engine off, key on, and what you could do is actuate the injector and listen for the solenoid click, right? It should click where it to the point where you can hear it, and you would determine whether this ECM is actually sending the correct voltage signal to the injectors for it to operate properly. And another good one I like to use is cylinder compression. So cylinder compression is important. Say you have it is more of a mechanical failure where you might have low power, some excess smoke. You could do this test to identify which cylinder is the weak cylinder. So as you can see here, it'll give you all the cylinders to monitor. And when you do the test, it's going to give you a result. So 100% doesn't necessarily mean it's 100% compression. What it means is that's the strongest, right? And then 98%, like as you see on cylinder 2, would be 98% relative to the strongest cylinder reading, for 100%. So this is a very important test for mercury systems. Sometimes with mercury, you have a fault or an issue with one of the components, one of the sensors, and it won't actually give you a fault code, right? They're kind of bad about that. But using this system checks auto test, you actually force all the actuators and all the sensors to work, and this actually creates a condition where it'll force the issue to reveal itself and actually display a fault code for you. So it's actually very important for mercury systems to have this test available and be able to use it.
Okay, then I'm going to continue with the last part of the diagnostics functionalities, which are going to be the advanced one when we're writing on the ECM. Okay, so as you can see, an omics tool can provide not only repair functionalities, but also configuration functionalities. That's also part of a diagnostics tool. Okay, so in this case, we have parameter change, engine location with a Mercruiser 5.7 MPI. If we are adding engines or we are just changing or putting new engines, we need to let the ECM know what's inside the vessel. So for that, you need a diagnostics tool to be able to do that functionality. Then what we have here is engine identifier. That's also part of parameter change. This is an example with a C2 BRP jet ski. Whenever you change the ECM or the engine, you need to change that identifier. So you need a diagnostics tool to do that example. Okay. Now with Evinrude, this is also a parameter change, injector coding. Injector coding is normally you see it on diesel engines. On gasoline engines, not that common, and also on the outboard side. But with Evinrude, which is quite technological, they do require to do an injector coding. So for that, you also need to have a diagnostics tool. In this case, well, you just need to read some kind of QR codes. You get a code and you just type it. It's super simple. That is an advanced functionality. More parameter changes. This is the keys recording. For example, this is especially useful for jet skis. You can do it like, for example, Yamaha, Kawasaki, Sea-Doo. At some point, you can use like a little plug connector for Yamaha and Kawasaki and follow some technical releases to do it. With Sea-Doo, we can do it with a diagnostics tool, and then we can just set if we want what type, if it's normal, learning, rental, etc. That would change the speed limitation. Then we have the calibration side with the digital lever, super important. This is an example with a Mercury Verado for the DTS, but it's also available in multiple brands like, I don't know, Yamaha, for example, Suzuki, and so on. Then adjust the trim limit. Okay, this is also important, and we see this with inboards and also outboards. This is an example with a Volvo Penta gasoline engine. Throttle valve actuator. This is an example with a Sea-Doo jet ski. You can also do this with a diagnostics tool. Okay, so this is a configuration. G3 service reset. Okay, this is needed. For example, we're in a Mercury outboard. When you're using G3s, at some point, we need, it's going to tell us the percentage of time remaining until the next service, and then we have to let the ECM know that we have done that service. Okay. And then the last one is the engine brake in. Okay, so we have here with some brands is needed when we buy a new engine, and we need to do and start again and do this functionality to lubricate the new parts again. This is common on two-stroke engines. Okay. Then we're gonna go to the extra features. Okay, so we have seen all the diagnostics functionalities, but we have more things that are needed for the technicians. Is part of the repair process, and this is going to be explained, and also the technical assistance part is going to be explained by our colleague Jose.
Thank you, Ignacio. So yeah, like Ignacio said, there's, not only do you need a diagnostic tool to be able to troubleshoot and find fault codes, perform tests, but you also need technical information, right? So some of the technical information that is, needed to properly perform a diagnostic and repair on a vessel would be some technical data. In technical data, you can see adjustments and tolerances, tightening torques. You need also troubleshooting. You have to have by fault codes and by symptoms. You have releases and procedures, vessel service data for maintenance, intervals. Uh, you also need diagrams, very important for wiring, functional fuses and relays, and system technical data, components and information. So for example, system technical data. Say you have a issue with a coolant level sensor. You're not quite sure where this coolant level sensor is. In system technical data, you are able to find the location of the sensor and see a picture or a description of what that sensor looks like. A lot of times it'll also give you specifications on resistance readings, values that you can check, and very useful. Diagrams, very important. Diagram is probably one of the most important things to have. If you have an electrical issue or an electrical problem, the diagram is your best friend. So it would be very difficult to diagnose an electrical issue without knowing which pins on the connectors to check on the ECM side or on the component side. So here you can, as you can see, depending on the ECU you would have, you would need the diagram or the pinout of each connector of each of the ECU. And you would need to know which pins on the connector to check. So moving on to maintenance data. Maintenance data is also very important. Maintenance data is going to give you the information on your different maintenance intervals. So say check, for example, very simple, engine oil. Engine oil has a shelf life. So many engine hours are going to require an oil change, engine oil filter change, things like that. With this information, you can check how many engine hours these services need to be performed. And another one, another good one. So with vessel data, you also have things like torque specs, torque sequences. If you want to perform a repair after you've performed the diagnostic, successfully, you would need to get this information. It's very crucial to have this data because a lot of critical components like a cylinder head needs to be torqued at a certain value in a certain sequence for it to be successful and not have any early failures. And troubleshooting by errors and symptoms. So troubleshooting by errors is self-explanatory. You have a fault code, you use the troubleshooting guide step by step and follow that guide, and you'll be able to, as seen in the first picture, and you'll be able to figure out the issue as long as you follow the troubleshooting guide. Another one, if you don't have an error, you have a symptom. It's very important to have a troubleshooting by symptoms information. So for a lot of cases, engine won't start, engine cranks but doesn't start. This is where it will be very useful. So you can go through the process of troubleshooting by step, using a troubleshooting by symptoms and without a fault code. And cloud sharing. So cloud sharing is very useful. So with cloud sharing, you can have quite a few. You have quite a few tools. It's like in my opinion, it's like a whole another tool on its own, where you can manage your workshop. You could create work orders, create tasks, manage your tasks by users. So you can actually assign each employee or each user different tasks or different access levels with the software, with the tool. So say you have a more advanced technician in your shop, and you could give him full access to perform any function with the tool. Some newer technician that is learning, you might want to restrict some access, right? In case they might do something that might be bad. You can also, with this cloud sharing network, very important, you create reports, diagnostic reports, maintenance reports, and work orders. Why is that useful? Because after you do all the work on the vessel, you've diagnosed, you've troubleshooted, you want to be able to create a report so that you can bill a customer, you can keep it for your documents so that you can keep a history of what has been done on that vessel, and if it's in your fleet. And you could create a vessel list. So say you need you would like to have a list of all your vessels and keep track of all their maintenance and and all their previous repairs. You can also do that. So customer technical support. So this is a very important thing to have. If I know that in the field, sometimes we have issues where we've tried things. We've gone through troubleshooting. Things haven't worked. They haven't you haven't been able to find the solution. So with a good technical support, using a multi-brand diagnostic tool, you're able to get feedback. You're able to get remote assistance in case you need somebody to connect, take a look at something isn't working as it should. That's when you get that remote assistance. You could contact by email, phone, and there's local customer support. So technical assistance. Alrighty, let's see. So technical assistance. There's going to be a few key things that are going to be common in technical assistance, right? So for example, say there's issues connecting to a certain system, right? First thing that, calling a technical assistance line for a multi-brand tool, you can connect to a system. What are they going to ask? What's your battery voltage? Do you have the proper battery voltage to connect to that system? Because the ECU needs to have a certain voltage to be able to communicate. Engine doesn't start. Do you have fuel in the tank? The ignition key. So are you getting proper voltage from your ignition key? Things like this. Engine start, or does the engine crank? A lot of things fall into these checks. Same voltage as the ECM that goes into battery voltage. To allow communication with certain ECMs, you need to have the same voltage that system operates on. And identifying the correct ECM and cable, very important. You might want to connect to an ECM or a system and you're not able to. What are you going to do? You're going to have to Well, calling the technical support, you're able, with their knowledge, they're able to guide you into identifying the correct ECM you're working on for that system, and uh, guide you into using the proper cable, because as Ignacio said earlier, each ECM, each system has a proprietary cable. And these are some case study examples. So for number one, issue clearing a fault code after replacing a component or sensor. You get a fault code, say low oil pressure, right? Okay, you change the oil pressure sensor, but you can't clear the fault code. What do? With customer support or technical support, they would guide you in, going in the right direction. So, for example, is the FMI related to voltage? Do you have a shorted low, shorted high FMI indicator? Yes, then the issues with the wiring or ECM, right? B would be the fault code is indicating an out of normal operating range condition. Example, low oil pressure fault. Not so in this case, it's not a voltage related issue. It's basically telling you that there is an issue with with your oil pressure. So in this case, technical support would guide you into connecting a mechanical gauge to the oil pressure system and verifying if you do have oil pressure. Very important. So another example, engine won't start. Call customer support line. My engine won't start. Well, there's two situations here. The engine will crank but won't start. So your engine is spinning, but it's it just won't crank up. Using a diagnostic tool, you can monitor commanded and actual fuel rail pressure. Are you getting the required fuel pressure for the engine to be able to start? That's very important. And then obviously, if the engine will not crank and will not start, then we would probably guide you in verifying the battery voltage, verifying the voltage to the starter, test, and then obviously if the engine has to be able to turn by so if it cannot turn by hand, it is seized, and you won't be able to start the engine. So testing your communication. An example, you're trying to connect to a system, you're not able to connect. There's issues with the different ECUs communicating with each other. There's different things that you can check. So in a CAN system, you need 60 ohms, right? There's two terminating resistors, and in a parallel system, it's divided by two. So what you do is you get a multimeter, and you put one of your leads on CAN high, one of your leads on CAN low, you check for ohms. If you have 60 ohms, that's good. That means that both terminated resistors are working properly. If you test with the multimeter and you get 120 ohms, that means one of the terminating resistors is bad and you only have the one doing the work. So that's obviously not gonna communicate. So direct current multimeter mode. So in this case, the positive lead to the communication pin and the ground lead to any screw without paint. So obviously ground, and that would be where you would check your voltages. Are you getting your proper voltage to the K line, right? In this case, we're going to talk about the K line. The bus test cannot be performed, but we can still use a multimeter. The thing about K line, for K line to communicate properly, it needs to have, it works on 80% of battery voltage. So for example, you have a 12-volt system. You have to, when you check out the CAN line, you would need 9.6 volts for verifying if the K line is communicating properly. In a 24-volt system, you would need 19.2 volts. That's about 80%. So with two pins, as you can see, CAN line, you would have, or 1939, very, very common. You would have 2.5 on the CAN high and 2.3 on your CAN low. SAE 1708, two pins as well. So you would basically have on the A pin, you would have 1.3 to 1.4 volts. Pin B would be 0.5 to 0.9 on most systems, of course.
Okay, so thank you, Jose. For him, it seems like super simple to explain all these scenarios and cases, but it's super important again inside like an Olmecs solutions to have a team, a dedicated team that is able to provide those answers. Okay, so that's something important. Thank you, Jose. So right now, I think that we can open this a Q&A session. Okay, and we can answer some things. Some things were already answered through the chat, especially with uh, somebody asking about the coverage. I think it's on the chat, okay? But we have other questions, okay? For example, there's one asking, which communication protocols use the early Mercury with no G3 smartcraft, no? Before the G3 had the first and second generation with the 4 and 2-pin connectors. I think this is a question for Jesus.
Yes, the earlier Mercury used RS485. It's a protocol similar to J1708. Okay, they use a 4 connector pin and 2 connector pin for the earlier. So it's older than the obviously than the SmartCraft connector. And nowadays this kind of connector is present in the engines, but not for diagnostic application. It's for only application. Okay.
Okay, great. Well, Paul was asking about, pricing and everything, where to obtain more information. If you want, I can just put my website. We sell through distributors, so we have a huge lead of distributors. You can also contact us. I'm gonna put right now the website and the email if you want. And if you're interested in other type of tool, I'm sure that if you type like anything on Google, you will find a lot of options. But I'm going to type that so you have it everything there. Thank you. Um, Aeronautical industry, no, we don't do any. We work on many industries, but not the planes industry. Maybe in the future. We just started last year the material handling equipment project, so we have a lot of things to do over there. We never know. Maybe in the future, all the cars they fly, and we need to change our diagnostics to flying cars as well. But I'm gonna put for the other question the website. More questions. Also, is diagnostics possible through Bluetooth connection? Well, I think this can be a good question for Jose.
Yeah, so that definitely Bluetooth is actually very useful in marine. I know a lot of marine technicians do use the Bluetooth for different purposes. So a lot of it, one case is access with an inboard. For example, if it's a very tight engine room, and you sometimes for comfort, even for comfort, you don't want to have to be tied by wires. So Bluetooth is definitely possible. Also, it is possible to calibrate the digital levers, even if you have more than one helm, thanks to Bluetooth. So that's also very important. Using also Bluetooth, you can use the data recorder and operate the vessel and not have to worry about your link being in danger. So that's pretty useful in the marine industry and with multi-brand diagnostics is Bluetooth.
Thank you, Jose. Well, we're gonna do the last question because I think we have to finish like in 3 minutes. Well, the last one. Anyway, we can send an email with the other ones. Do you think Olmecs Diagnostics will be the way to go? As I was saying before, if we compare ourselves to other industries, you can go to the car industry, the trucking industry. I would say that the way to go is Olmecs, but Olmecs wouldn't exist without the OE. Okay, so we're just complements and we need each other. And if you go to the car industry, trucking industry, even dealers, you go to a truck, the truck is manufactured by a company, but then you have different systems inside, and you need like 5, 6, 7, 8 different systems for one just only truck. So dealers are using Olmecs tools to having things easier and being more efficient. Coming back to the marine industry, I think right now people they know that there's Omex platforms that they can be using, and the expectation of growth is very big. So I would say that it will be the way to go, but again, it's not a substitution. Okay, we need each other OE and Omex. Okay, So, well, to end, I would like to thank everyone. And this is going to be recorded as I said before. I hope you had a lot of fun. And well, as a reminder, as I said, you're going to receive an email with this. If you need anything on our side, you can send us an email on with the IBEX organization. You can contact them, and that's it. So thank you, IBEX. Thank you, Jesus. Thank you, Jose, for this, and thank you, the audience, for all your questions. This was brought by the IBEX organization, and see you in the next edition in October, because we're going to be there as well. Thank you very much.